Assalamu alaikum. I hope that everyone is doing well. We have to continue with the same unit, basic statistics, and the same topic, frequency distribution. We have to go with exercise 6.1, but before proceeding towards the exercise, let's have a revision of what we learned in the previous class. In the previous class, we learned about frequency distribution. Frequency distribution is basically the organization of the data, where data is classified into different groups in a table. Then we learn about types of construction of frequency table. On the basis of types of data, there are two types of frequency distribution: discrete frequency distribution and continuous frequency distribution. In case of discrete frequency distribution, the data in a class can take one discrete value like 0, 1, 2, 3, 4, 5 and 6 and so on. There will be no range of values. There will be a jump after, means each value like 0, then 1, then 2, then 3. Such type of frequency distribution is used for the data, like data about number of people, number of students, because we cannot record as 1.5 or 2.5, so therefore the value will be with a jump, as no one means the number of people cannot be 2.5, 10.5, so therefore the values will be with a jump. Whereas in continuous frequency distribution, the data in a class can take any value in range. For instance, we have the class here 0 till 1. So any value greater than 0 and less than 1 will be recorded in the first class. Such type of frequency distribution is used for the data related to height, weights or marks, as this type of data can hold decimal values as well. Then we discuss some of concepts involved in a continuous frequency table. The first one here is class limits. The minimum and maximum values defined for a class or group are called class limits. We have here 44 till 48. 44 is the lower class limit, whereas 48 is the upper class limit. So class limit basically give limits to that particular class, that the weight between 44 and 48 can be recorded in this class. Here we have class boundaries. The real class limits of a class are called class boundaries. Class boundaries are basically the real class limits. As in continuous frequency distribution, it's already discussed that it can take a range of values, and means we can say that decimal values can also be included. So if we just make the class limit like 44 till 48, so if any weight is 48.5, so that weight should be recorded in which class? So in order to overcome that problem, class boundaries are introduced. So what will be class boundaries? The class boundaries are the numbers that separate classes without forming gaps between them. As you can see here, here is a gap 48 then 49, but here is no gap 48.5 then 48.5. So such type of values can be recorded here then in that class. So this is the significance of class boundaries. Class boundaries are obtained by subtracting 0.5 from the lower class limit and adding that 0.5 in the upper class limit, like 44 minus 0.5 we will get 43.5, and 48 plus 0.5 we will get 48.5. so then it will be continuous. Midpoints or class marks. For a given class, the average of that class obtained by dividing the sum of upper and lower class limits by 2 is called the midpoint of that class. 0 is the lower class limit and 3 is the upper class limit. If we add 0 plus 3, then divided by 2, so we'll get 1.5, which is the midpoint of that class. Here we have cumulative frequency. The total of frequency up to an upper class limit or boundary is called the cumulative frequency. In cumulative frequency, the frequency is added up in each successive class, like 3, then 3 plus 8, 11, then 3 plus 8 plus 9, then 20. Here we have exercise 6.1. The following data shows the number of members in various families. Construct frequency distribution. Also find cumulative frequencies. Here we can see that data is about the number of members in various families. So since number of members cannot be in decimal, so this type of data can be presented by a discrete frequency distribution. Moreover, we have to find cumulative frequencies too. So for discrete frequency distribution, the first step is to find the minimum observation, means the minimum value, and the maximum observation. In this data, the minimum observation is 2, whereas the maximum observation is 12. So we can take a start from the minimum observation and we can proceed towards the maximum observation. Here the minimum observation is 2, then 3, then 4, then 5, then 6, 7, 8, 9, 10, 11, then 12. Now this tally mark is used to record the observation. Like 2 exists 1 times in the data, so 1 tally. 3 exists 1, 2, 1, 2 and 3, so 3. And 4 exists how many times? 1, 2, 3, 4, 5, 6, so 6 is the frequency, and 5, then 6. Then 5 exists how many times? 1, 2, 3, 4, 4. And 6 exists how many times? Let's count the number of 6. 1, 2, 3, so 3 times, and so on. Here if we see 12 exists just 1 time here, so 1. Now if we add up the frequency, so it will be 39. If we count the number of data or the number of observations, so it also will be 39. So in this type or in this way we can verify it. Next part of the question is that we are going to find the cumulative frequency, which is already discussed that in cumulative frequency the frequency is added up in each successive class. So 1 plus 3 4, then 4 plus 6 10, then 10 plus 4 14, and so on. So at the end we will get 38 plus 1, it will be 39. Here we have question number 2. The following data has been obtained after weighing 40 students of class 5. Make a frequency distribution taking class interval size as 5. Also find the class boundaries and midpoints. Here the data is about the weights of the students, so we can make continuous frequency distribution. Though here we cannot see any decimal value or any observation with points, we can make frequency distribution. We can make continuous frequency distribution here. Okay, it is said here that taking class interval size as 5. So let's first understand that what class interval is. Class interval refers to the numerical width, or we can say class size. It is defined as the difference between the upper class limits or lower class limits of the two consecutive classes. We can see here that 20 is the lower class limit of the first class and 25 is the lower class limit of the next class. So 25 minus 20 will give 5. Similarly, 29 is the upper class limit and 24 is also the upper class limit of the first class. So 29 minus 24 will give 5. So this is class interval size and it will be same for each class. Okay, then we have to find the class boundaries and midpoints as well. Here we can take a start by making the frequency distribution. So for that, first of all, minimum value should be found, and then maximum observation. Here the minimum value is 21 and the maximum observation is 41. So we can take a start from 21 and we can end till 41. It's given a hint here, then we can take a start from 20 till 24 because it will be easy if we will take a start from 20 rather than 21. So 20, then 24, then after 24 we have 25, then 29 as the hint is given here. Then after 29 we'll be having 30, then 34, 35, 39, then 40, 44. Make sure that the class interval should be same. If we just subtract 25 minus 20 will get 5, 29 minus 24 will get 5, 30 minus 25 will get 5, 34 minus 29 will get 5, and similarly for the other classes. Now we have to record the observation here, that the weight of the students which are between, or the weight of the students with between 20 and 24 will be recorded in the first class. So let's find out how many observations lie in the first class. So let's see here that 24 is also inclusive here. So one observation, then two, then we can go ahead, two, then three, then four, then 5, and then you can see 6. So 6 observation here, 5, then 6. Now we have to see that between 25 and 29 how many observation or how many students are with weight between 25 and 29. So we can see here 1 means okay, no, this one 26 can be 26, 1, 2, 3, 4, 5, 6, 7, 8, 9, and probably it will be 10. You can check it yourself, and in the very same way you're going to find the observation and you can record by tally marks. Then you have to write the frequency here. This is 12, 5 plus 5, 10, then 2 more tally marks, so it will give you 20. If you will add up this, it will give you 40. As 10 plus 12, 22, 22 plus 6, it will be 28, 28 plus 3, it will be 31, 31 plus 9, it will be 40, and you have to count the number of observations here, so it should also be 40. And here we are going to find the next part of the question is that we are going to find the class boundaries and midpoints. So let's first of all find the midpoints, because this is easy. As it's already discussed that midpoint is the middle value of the class, so we have to add the lower class limit with upper class limit, and then we have to divide it by 2. So 24 plus 20 will be 44. 44 divided by 2 will give 22. 27 will be the midpoint of this class, 32 will be the midpoint of this class, 37 will be the midpoint of this class, and 42 will be the midpoint of the last class here. Let's go ahead with the further parts of the question. Here it is asked, let me find, we are supposed to find class boundaries. Moreover, we are supposed to find make less than cumulative frequency distribution. So let's understand what less than cumulative frequency distribution is. So this is the class limit, the same. Let me tell you here that for making less than cumulative frequency distribution, we have to add one more class, means preceding class, like it's 20 till 24. So you have to think that if a class will be means prior to that preceding class of this, what it can be. So keeping in mind the class interval, we have to make the class as if we have to write 15 here. If we will write 16, so 20 minus 16 will be 4. The class interval will not be 5 then. So 15 and 19 is or maybe the preceding class. So here we have to make the class boundaries for first for as it is required here, as it is asked that we have to make the class boundaries as well. So in class boundaries, we have to subtract 0.5 from the lower class limit, and we have to add 0.5 to the upper class limit, so that the values or means the numbers which will separate the class, it will be without the gaps. Okay, here 25 minus 0.5 will give 24.5 and 29.5. So here are the class boundaries. Now as we know that we don't have any observation between 15 and 19, so the frequency here will be 0, and the rest frequencies are same as it is recorded here. Then we have to find the cumulative frequency. We have to add the frequencies in each step and we will get 40. Okay, these all are done for making the less than cumulative frequency distribution. Okay, let's understand what is less than cumulative frequency distribution. For less than cumulative frequency distribution, we have the we have to take the upper class limits, upper class boundaries, as class boundaries are the real class limit. So upper class boundaries are 19.5, 24.5, 29.5, 34.5, 39.5, and 44.5. So here you will come to know about the use or the significance of cumulative frequency or less than cumulative frequencies. Suppose we are interested to find out that less than 19.5 from here, as our data starts from here, that less than 19.5, that how many students are with weight less than 19.5. So as we have the weight, the weight starts from 21, so less than 19.5, there is no any student with the weight less than 19.5. Now we are supposed to find that how many students are with the weight less than 24.5. So less than 24.5 are how many? 6. Now we are supposed to find that less than 29.5. How many students are with weight less than 29.5? So 10 plus 6, 16. Less than 34.5. How many? 12. 10 plus 6. So it will be 28. And less than 39.5, all the students will be less than 39.5, and less than 44.5. So all of these will be, means all the students are here, means all the 40 students are less than 44.5, because the maximum weight is 41 here. So this is the use and the significance of cumulative frequency. Here we have question number 3. From the following data representing the salaries of 30 teachers of a school, make a frequency distribution taking class interval size of ₹100. Here we have the data, and here a hint is given that we have to make the classes 450, then 549, and like, so that the class interval size is 100. If you subtract 450 from 550, so you will get 100. If you subtract 449 from 649, so you will get 100. So this is the class interval size. Here the minimum value is 450, and we have to find the maximum value, which can be, I think, 1240. So you can write the minimum and maximum value, then we can make frequency distribution here. This is the frequency distribution table. As following the hint, we can make the classes here. After 649, we can take 650, then 749, 750. Then in the very same way, since the large means the maximum observation is 1240, so we have ended up here with 1249. As if you write here 40, so the class interval size will not be same. Then we are going to record the tally marks. Here we have to see it yourself that between 450 till 549, how many observation. Like we can see here that 450, instead of this we can mark one tally, then we can take, as the range is still 549, so 500 will also come. The rest will not come because 550 is greater than that. So 2 tally marks, and in the same way you can go with the rest. Here we have the frequencies, and you can write the frequency here, and the total will be 30, as we have the salaries of 30 teachers which are recorded here as a raw data. Here we are done with 3 questions of exercise 6.3. This is all for today. Hope you have understood the concept and the question. Here is your assignment for today. You have to do exercise 6.1, question number 2 and 3 in your neat notebook. Have a nice day. Stay blessed.